The human body is an interconnected and sophisticated system. Each of its organs play a role in processing information and making decisions. And once again, it's the same in computers. Program execution is undoubtedly an indispensable part of a computer. But have you ever imagined how a computer works? How is it connected with the human body? How do computer components work together? In this video, we're going to use the simple computer that we built last time to demonstrate how modern computers execute programs. Let's try to make the computer count from 0 to 9. First, let's input the instructions to the computer. To count from 0 to 9, the machine has to follow these instructions. Start from 0, print the number to the screen, add 1 to the number, and finally repeat until we reach number 9. Then we stop the program. Now of course, machines can understand English, right? That's why we have the first step, compilation, to basically translate these human language commands into machine language. This is also why we have programming languages, in order to make compilation into machine code easier. The commands we just inputted will be allocated into the RAM's multiple memory blocks. When this is done, the CPU will use the memory allocated in those RAMs to proceed its instruction cycle: fetch, decode, and execute. The CPU components include the arithmetic logic unit, or ALU, where all the mathematical calculations happen, the registers, which hold temporary memory, and the control unit, or CU, which, well, controls everything that happens around the CPU. First, the control unit will fetch the first command from the RAM and store it on the register in order to be processed. Next, it will decode the command that it just fetched so that the ALU knows what to do. And finally, the command is sent to the ALU to be executed. The result of the execution will be stored back into the register. After all that is done, the registers will point the CU to the next command's memory address, where it will again do the fetch, decode, execute cycle. This process is also the same with the next command. When it executes the repeat command, however, instead of pointing to the next memory address, the registers will point the CU back to the second command, where it will be executed again and again. This way, the program will be able to output every single number from 0 to 9 on our computer screen. And thus, our program execution is complete. In summary, we have learned about how program execution works on a computer. First, our instructions will be compiled and then allocated into the RAM, and then after that, it will be sent to the CPU, where it will do the instruction cycle of fetch, decode, and execute. This is the end of our hardware playlist. Thank you all for watching.